All right. In this episode, we are going to continue with our locked door functionality and expand it by adding keys. And to do that, we're also going to have to add a player inventory. So before we get started, let's take a quick look at where we left off. Our door, it has special locked text that shows up when the door is locked as opposed to when it's unlocked. And it has a special sound effect that if I try to interact with it while the door is locked, I get a locked sound effect. And then at this point, I have to actually select the door in the editor and just uncheck that it's locked. And I can see that now it just says door instead of locked. And when I open it, when I interact with it, it opens and plays a different sound effect. So our job is going to be to create a different type of interactive object. It'll be an inventory object, and specifically we will make it a key. And so when the player selects it or interacts with this key inventory object, rather than just being like a switch like these are, it will actually remove the inventory object from the scene and sort of magically appear in the player's inventory, which we won't have any kind of visual for yet. That'll be a different video. But conceptually, the object will be in my inventory, and in data under the hood, the object will be in my inventory. And then when I try to open the door, while I have the key in my inventory, the door will unlock. So that's what we're going to do. So right off the bat, I know there are a couple scripts I'm going to need to make. I'm going to need to make a player inventory script and a inventory object script. I think it makes sense to make the inventory object script first, so let's go ahead and do that. I'm in my scripts directory here. I'm going to go to create C# script, and let's make the inventory object. And then I'll just double click it to open it in Visual Studio. Alright, so here's our new inventory object script. This thing, well, right off the bat, let's just clear out start and update so I don't forget them in there. If I need them, I'll add them back. And I know that this inventory object is going to work very similarly to our interactive object, in that it's a thing that is an interactive, meaning the player can walk up to it, look at it, and interact with it. And so it will have the whole interact with method. It'll have display text. I need it to say what the thing is when the player's looking at it so they know what what it's going to sort of do when I interact with it. And I want it to have a sound effect. So all this is telling me I should probably just go ahead and make my interactive object a child. I should make inventory object a child of interactive object, just so I get all that stuff for free. So rather than making it a child of mono behavior, I'll go ahead and make it a child of interactive object. So inventory object is a special type of interactive object, essentially. Now, when I think about what an inventory object needs to have, it's definitely going to need the display text that every single interactive object has, meaning the text that the player sees when they're looking at it in the world. But one day I also want to have an inventory menu, like a UI menu. So the player would hit a button and then this menu would appear and it would list the player's inventory. And so every inventory object that the player has would appear in this menu, and I could click it and I would see a special name for the object. Each item should have like an icon or an image for it in the menu, and it would need a longer description text. So like if I select an object, it would have a longer description text, so I could like select a note and read all about some secret note that got left behind, sort of like we might see in a Resident Evil game. So I'm just going to make some to-dos to remind me about this stuff. So to-do is kind of a neat feature in Visual Studio. Let me just type it out and then we can talk about it. So I'm going to have a to-do, and it's going to say add long description field, and to-do add a field for an icon. And we'll just leave it at that for now. So the neat thing about this is, I'm not making that menu yet, so I don't care about this stuff. I just want to remember it. And the neat thing is in Visual Studio then, if I were to go to the View menu here and then choose Task List, you can see these to-dos are here. And let's say I was looking at this script, and then I double-clicked one of these to-dos, it will take me right to it. So this is just a neat feature for remembering stuff you want to do later. I recommend playing around with it. Okay, so honestly, this is good enough for inventory object for right now. I know it doesn't seem like we've done much, and we'll definitely revisit it, but it's enough that we can now go back to Unity and create the other script I mentioned, which is going to be the player inventory script. So create another C# script, and let's just call it player inventory. And this script is going to be a spot where we can keep track of all of the things the player has picked up or added to their inventory. So let's go ahead and open this one in Visual Studio. And if you get this message, you can just hit reload. And now there we go, I have my player inventory. Now again, I'm just going to clear out start and update. And for this particular case, I'm actually going to get rid of mono behavior. And I can explain why. Mono behavior is the sort of base class that every game object in Unity derives from. So this is like the parent class of everything that I could ever put in a Unity scene. But I don't think I need to put the player inventory in a Unity scene. It just needs to sort of exist as data that my other game objects can reference. It doesn't need to actually be physically present. And I can make another script later for the actual menu, which will need to be physically present, but this inventory is just sort of going to be the pure data repository for keeping track of what the players picked up. So anything that I would ever put in a scene, any script that's going to be attached to a game object in the scene, that would need to be a mono behavior, but this is not one of those. So let's make life more simple and get rid of the mono behavior business here. So this is just a plain old C# script class. C# class. And within it, I really only want a single thing. I want a list of whatever the players picked up. So for now, we'll just say list, which is a special type in C# that's kind of like a souped up array. And actually, I have in the notes here, you can learn more about arrays if you're foggy. And then also there's a nice Unity tutorial about lists and dictionaries. Dictionary is another type of collection that is in C# that's useful. But the one we're going to use right now is a list. And the way a list is different than an array is essentially, most importantly I would say, is you can dynamically add and remove things from it. So we can change the size of a list as we go. Whereas an array, you define the size right off the bat and it cannot change. So anyhow, we're going to use a list, and we have to decide, we have to tell C# what is the type of object that is going to go in this list. So this is, what is it going to be a list of? And this is going to be a list of inventory objects, right? And if I hit space, you'll see there's a name suggestion right here. And it's just inventory objects, plural, like this is a list of these things, so let's just call it inventory objects. I'm okay with that name, except one caveat, and that is I want to use Pascal case for this because I need to be able to access this list from other spots. I'm going to need to be able to, at a minimum, I'm going to need to be able to access it from here. So that means this list needs to be public in some way, so it'll probably be a property. And our naming convention for properties is to use the uppercase, Pascal case. So we'll go ahead and use that naming convention. And next, I'm going to say this thing is going to need to be public, like I just mentioned. And I want it to be a property, so I have to figure out what kind of property syntax I want to use. The most simple is to make sort of write it like this. So this is the auto. This is a syntax for an auto property or an auto implemented property. And it's just a short version where we don't have to actually define a getter or a setter. And so we can do it all in one line. And basically when you do it like this is just going to work like a regular old variable. Nothing fancy happens. You can just assign to it or get its value just like any other variable. But we will be free to later modify these and add functionality if we wanted. On that note, there are some special things we should do with this property. I think we want to make sure no one else can, or just no one period, can set the value of this, because we don't want anyone to change the actual list. We don't want to say, hey, you know what, inventory objects is now pointing to this completely different list. We don't want to do that. People will be able to add and remove inventory objects to and from the list, but we don't want them to actually change the entire list itself or point it to something else. And the other thing to keep in mind, so that's why I got rid of the setter. So now no one can change the value of this itself. But the other thing I want to do is initialize my list. That's just part of lists. You always have to initialize them before you can use them. It's kind of a common error people run into before they get used to using lists. So the easiest way to do it is to initialize it just as soon as you declare it. So we'll say that this list equals a new list of inventory objects, just like that. So we're basically calling the list constructor here. And this is a new thing you can do in Unity, actually. You didn't used to be able to initialize properties like this with an equal sign after them. It's only available in 2018.3 and later, essentially. And if you happen to get an error trying to do this, you can double check that you have your, if you go to Edit, Project Settings, and go to the Other Settings, and scroll down to where it says Scripting Runtime Version, just double check that you're on the .NET 4.x equivalent. This just became the default in 2018.3. Previously, this was the default, but now you can see this is deprecated. So this just means that you can use newer C# syntaxes and features than you used to be able to in Unity, which is why something like this will work. And as recently as 2018.2, it would give you an error. So if you get an error with this, you want to check the project settings like I just showed you. One of my students had that error just yesterday, so I wanted to mention how to fix it. Anyway, we're making this new inventory objects list. We are initializing it right in the same line. Now the next question here is, how can I get access to my inventory list in my inventory object script? Because basically what we need to do here we need to overwrite the interactive objects interact with method. So let's see. Since this is the interface method, we have to say public override interact with. And so in here, this is the code that will get executed when the player clicks on the inventory object. I need at this point to add the inventory object to this list. So somehow I have to get access to that list from inside of here. Now the most common way to do that would be to make an instance of the class. So I would have to say something like player inventory p equals new player inventory, and then I can say p dot inventory objects dot add, and then add this thing, right? But this is problematic because then every time the player clicks the button, we're gonna make an all new player inventory, and we only need one of these things. So we want to actually make sure there's only ever a single player inventory, and the neat thing about doing that is it actually makes it easier to access it, and you have to write less code to get a hold of it. So there's two things to know about when you only want to have one class ever. One is the Singleton Pattern, and the other is statics. And so I really encourage you to read about the Singleton Pattern here. You can find the link in the notes. But the interesting thing about Singleton is it's problematically overused. And so you can see that this chapter of the book is actually telling you how not to use the Singleton Pattern. So I'm not going to go into it too much, but I'm just going to explain that if you read this article, you'll understand there's a simpler or better way to do what we need to do in this case, and that's going to be using statics. So if you're not familiar with statics, this is a good time to pause and check out the Unity tutorial about statics. But basically, long story short, statics will make it so that there can only ever be a single instance of a thing. So I don't really need to make this whole class static, although I could. If I make the class static, everything in it has to be static, and that's not really a problem because this is the only thing in the class, and this is exactly what I want to make static. So public static, and this just means there's only ever going to be one of these things. I'm not gonna mark the class as static. I don't know why. I guess just because I don't need to, and so I won't until I need to. Maybe I should. It's just kind of, I suppose the advantage to doing this is it makes it clear that you're not supposed to go around instantiating, creating new instances of this. So I'll go ahead and mark it as static, even though I could have gotten away with not doing it. I think this expresses the intent more clearly and enforces it too, because now I actually can't go in and say player inventory p equals new player inventory, at least I don't think, because that's static. So you can see I actually get a little error message that says you can't do that. So that's why I made the whole class static, even though I didn't need to, is just to make it impossible to use it wrong. Alright, so the neat thing is I get to skip all that junk. I can just straight up say player inventory dot inventory objects. So I get it's like you get a free reference to this thing without ever having to make an instance of that class. So it's pretty cool. And I can do this in any script in my whole game. I can just straight up type in player inventory dot inventory objects and have access to it. So it's pretty easy. So what do I want to do when the player actually interacts with my inventory object? Well, there's basically two things. I'm going to make some notes here. So let's just add a quick summary and say when the player interacts with an inventory object, we need to do two things. So one, add the inventory object to the player inventory list. And 2, we need to remove the thing from the world to kind of convey the sense that you've picked this thing up and are carrying it with you now. If we leave it in the world, it doesn't really make sense that you've removed it from the scene. So we need to remove the object from the game world. Alright, so those are the 2 things. So the first thing is to add it to the list. So player inventory objects.add, and what do we want to add? Well, we need to add an inventory object. What inventory object do I want to add? I want to add the very one that the player clicked on, right? So the way to get a reference to the very one, the very script you're inside of writing code in, is to type this. So we want to add this very script to this list here. Alright, so that should take care of part 1. Part 2 is we have to remove the object from the game world / scene. So we could do something like this. We could say destroy this, and that would get rid of it totally. It would destroy the whole game object. But the problem is we need to keep track of this script, of this instance of the script, because if I kill it, it will also kill it from this list. So when you tried to look at the list of inventory objects, the thing that we thought we added there has actually just been destroyed and is no longer a thing. So we can't go that far as destroying the whole script. Instead, we just need to sort of make it appear that it's gone from the scene. And so let's just take a look. Let's just kind of save and go back to Unity and kind of think about this a little bit. So why don't I make an inventory object? I'm going to hit Control-Shift-K to get the shape tool open. And I'm going to pick a unique shape, something that reminds me of a key, or is close to a key, I guess. Something that I'm not using already. I don't know. So I'm going to choose Prism, and I'm going to leave the default settings here. And I build the thing and close the shape tool. And now I've got this prism, which is going to eventually be my key, but for now it's just going to be a generic inventory object. So I'm going to select this game object, and I'm going to add my inventory object script. You can just start typing inventory object, and there it is. Now remember, since inventory object is actually a type of interactive object, I can see right away it's got some stuff built into it, like it has a display text, and it's actually the default display text is saying this is an interactive object, which isn't a lie, but it's also not specific enough. So let's go ahead and change it so that the default display text actually says inventory object. And so remember the trick to that, we can look at our door to kind of remember how we did that. We had to make a constructor, and the reason is we cannot override a field like this. So I can't override this in a child. It's just not something you're able to do. You cannot override fields. You can override properties, but not fields. And this one is a field. So instead, we have to make a custom constructor and assign the value that we want in the constructor. So I'll just do that same thing here. So in my inventory object, before my interact with method, I'm going to say public inventory object. So that's just the syntax for a constructor, is to use the name of the class almost like a method. And I'm going to say inside of this constructor that display text equals name of inventory object. And this means it's going to convert the name of this class to a string and then store that value in the display text field. And so now if I go back to Unity, make sure you save, go back to Unity. I'm going to rename this thing instead of Prism. Let's call it inventory object, and I'm going to reset it. So I'm going to right click on this and choose reset. Because remember, changing the default values will not change instances that you already have in the scene. So it only changes new ones, or if you choose reset, it'll reset it to its defaults. And now I can see that this is going to say inventory object when I look at it. So if I press play, I'm going to go look at it and it's an inventory object. Cool. And that, technically clicking it's going to add it to the inventory, but you'll never know. And I can keep doing it over and over, and that's not a good thing. So anyway, one more thing I want to do while we're just looking at this, let's quickly, remember we got the sound effect on here too. Let's get a sound effect for inventory objects real quickly. I have one that I've found, it's like a bag sound. So I'm going to use this. You could use whatever you wanted. If you wanted, you could try to make a custom sound for every inventory object based on whatever it is. Like say if it's a key, I could have like a bright key sound effect when I pick it up. If it's like a drum set, I could make it sound like drums when I pick it up. I don't know, but I'm too lazy to make a special sound for every single object in my game, so I'm just going to get this one generic one, kind of similar to something I think of as like in WoW when you opened the bag. It's kind of quiet. Anyway, download this or whichever sound you like, and we're going to need to add it into our sound effects directory here. So let me find mine and drag it in there real quick. Okay, here it is. I will play it, make sure it's the same thing I'm thinking of. Cool. Alright, so I'm going to select my inventory object, and I'm going to drag this sound effect into its audio clip in the audio source component here. And I need to make sure I uncheck play on awake. So I'll just uncheck this, and now it will not play the bag sound effect as soon as I start the game. And I can just confirm that when I go over here and click on it, it will play the sound effect. And that's cool. It's playing the sound effect because I am calling base.interactWith in my inventory object.interactWith. And remember, the base class is interactive object, and you can see it has this whole audio source.play logic inside. Okay, that's cool. Now remember, we were working on figuring out how to make this thing look like it's disappeared, but yet not completely destroy it, because otherwise it won't appear in my list. So let's think about that a little bit. My advice for things like this is to find the object in the editor and figure out, like, what are these things, if I turn off, is kind of giving me the effect that I want. Or maybe it's not as simple as turning off. Maybe it's adjusting a value. Like if I want something to rotate a certain way, let's play around with the values and see if which one I need to actually change in code. So in this case, I believe the mesh renderer component is essentially what is making this thing visible. Renderers are always going to be your go-to when it comes to making things draw on the screen. So if I turn that off, it's an invisible inventory object. But check this out. This thing is no longer visible, but if I snoop around, I can probably still find it. I might need to cheat and look in my scene window. So let's put the scene window somewhere where I can see it. And there it is. You can see I am looking at the inventory object now. So even though it's invisible, I can still look at it, and I can even click it. Yeah, sorry, this is it's hard to interact with invisible things. So you can see I'm clicking it and everything. So that got rid of it visually, but that's not good enough, I guess, is the idea here. So what else do I need to do? How do I make it so that I can't click on it? And also, I don't, you couldn't tell this, but I was getting physically blocked by it because it still has the collider there. And so conveniently, not only is the collider responsible for blocking me, so if that's problematic and I don't want it to block me when it's supposedly gone, I can turn the collider off. But also, the collider is also what's used for hit detection with my raycast. So this, if I turn the collider off, not only will I not be blocked by it when I try to walk through it, but I won't be able to like look at it and activate it anymore. So if I turn the mesh renderer and the mesh collider off, this thing is as good as gone from my scene. You will see I can't click it, I can't see it, I can't get stopped by it. So by experimenting in the inspector here, I've figured out the two things I need to turn off in my script to give the effect that the game object has been removed from the world. So I can add more to this. I can say something like can't use destroy because I need to keep the game object in the list, inventory list. So we just remove or disable the collider and renderer. Alright, so this is what we want to do. Now we just got to do it. We need essentially references to these things. So I'm going to make two fields, one for the collider, one for the renderer. So we'll say private, what's it called? Well, so you can see this is actually called a mesh renderer, but I think there's kind of a more generic class for it that we could use. So I'm just going to say private renderer, and then I'm going to make another one. Oh, well, you know what? So here's the thing. If you ever see this is kind of similar to like if I were to say private rigid body. Unity has, at least at one point, they had built-in references to these kind of common common components, so that you could just like, I'm going to comment these lines out, so that you could just like wherever you wanted, I could just go ahead and say renderer dot whatever I wanted to do. So in this case, it would be like enabled equals false. But you can see this isn't really working anymore. They realize that this is just opening the door for people to use components that don't exist, because not every game object is guaranteed to have a collider or have a renderer or have a rigid body. For example, my inventory object here, it does not have a rigid body, so if I tried to use the rigid body, it wouldn't work. It would give me an error, a runtime error. So you can see it says that component.renderer is obsolete. It's deprecated. Use get component instead, whatever. So anyhow, I am going to, this is problematic because they've stolen the good names and yet you can't use them. So there is a trick to get this little green underline to go away. So I don't need a rigid body. We're just dealing with this renderer. And it says, if I mouse over, it says, this is hiding this built-in one, the same one that it says is deprecated and you're not supposed to use. It says, use the new keyword if hiding was intended. So in order to make this stop giving me annoying reminders, I can say, I can put the new keyword in there. So it will be private new renderer, and now it's fine and I can use the good name. Same thing with collider, ironically. I could say private collider which is like the base class of all the colliders. There's different types of colliders. There's like circle colliders and mesh colliders and whatever. You can see I have the same whole problem. So I'm going to use the new thing here also. And this is not a thing you normally need to do. It's just in these weird special cases for these very common components, Unity has stolen the names and still refuses to give them back to us. And hopefully they will one day. But in the meantime, you can just use the new keyword. Anyway, now I have fields for these things. But if I were to try and use them, it wouldn't work. If I said something like collider.enabled equals false, which is just, this is how you disable components. You say enabled equals false, and it would be just like unchecking or checking this based on whether you set it true or false. Anyway, this won't work for us because we have not initialized this variable. So it's a good idea to initialize stuff in the start method. So I will say inside of start, I'm going to say renderer equals get component renderer. Oops. And remember, get component, it just searches the game object for the first renderer it finds, stores it in there. So if you had more than one, you'd have to be more careful about how you're doing this. Same thing with collider. I need to say collider equals get component collider. And in this case, it's not super uncommon to have, it's not unheard of to have multiple colliders on an object. So again, remember that get component will just find the first one. In my case, I only have one, so that's okay. And now all of a sudden I can type collider.enabled equals false and it will work. Same thing with renderer. I need to make sure I say renderer.enabled equals false as well. And save. And now I think this will sort of hide our game object like we wanted. So some of you might wonder, rather than putting this in start, what if I just went ahead and did something like this, where I said get component renderer dot enabled equals false, right? So this would work also, but I want to warn you that it's a good habit to get in where you will cache the results of your get component functions. The idea mainly is that calling get component has a bit of a performance implication. It's not the fastest method you can call. And so if we wait to call it until the middle of gameplay, like right here when the player's actually clicking a thing, more than likely it'll be fine. Especially in this game so far, it's mega simple. But the more I do it, it starts to add up. So it's better practice to make this a little bit expensive search function. It's a good practice to do that in start, which is happening before the player actually ever starts even playing the game. So they will not notice this little hiccup. And we could even, if it gets noticeable, we can make a loading screen, right? But this allows us to do the heavy lifting before the game starts and not try to do it at a critical moment so that there's a slowdown or hiccup in the middle of gameplay. So that's why we don't want to call get component here. And another thing is, now that I've cached this, cache just means like saving it in a variable. So in this example, I'm not saving it. I'm just grabbing it and using it once and then letting it get disposed of. Well, the problem is if I ever want to use it again, like if I wanted to be able to drop this back into the scene and then so turn it back on basically, or do anything else ever again with these, you would absolutely want to cache the value, which means save it in a variable so that you can use it later. And the reason is that just saves me from having to call get component multiple times, right? This way I only call it once and I can use this forever. But if I don't save it, I have to call get component every time I want to use it. And so again, it's just more and more calls to this function that's not, it has a bit of performance implication to it. So we only want to call it when it's necessary. All right, so anyway, I'm going to go ahead and delete this. This was just an example. So I think this works. I think if I save it and make sure you got everything saved, go back to the game, I think now when I collect my inventory object, it will actually go away and play the sound. And so let's test it out. Cool, it worked. I'm going to change the vertex. I'm going to add a vertex color to this just so it stands out easier against the white floor. So vertex colors, let's make my key yellow. Why not? Okay, so let's admire our yellow key in our world. It is gone. And so I can look at the console and see that it says the player pressed interact button. The player just interacted with inventory object. Okay, that's cool. But I want to know really more about what is happening with this. Is this working? Is this list filling up? So let's talk about how to figure that out without having to actually make a whole menu for it, which we will do later. So one thing we've learned about is using debug.log to sort of give us information about what's going on. That's a good way to debug things. But in this case, I want to show you a different way to debug using the actual debugger, which is much more powerful and allows you to dig much deeper without writing a bunch of debug statements. It gives us more control. So in order to use the debugger, we have to do a couple things. First, we need to put in a breakpoint, which just represents when this code is being executed, essentially the game is just going line by line, doing whatever each line says to do, right? So the breakpoint is saying when you get to this line, stop. And that's why it kind of looks like a stop sign, or it's red, right? So when we get to this line, stop. And when it stops and pauses, we are allowed to basically mouse over anything in this function and sort of see what the value of it is right then and there. And you can even add custom things to what's called a watch list, so you can see the value of pretty much anything at that particular point in time when the game has paused. So the first thing you do is you add that breakpoint. So I'm going to put it right here on line 35 so that when we get here, the game pauses. And we want it to pause here so that we can basically look at the value of the inventory objects list before we execute this code. So this will stop before this line of code is executed. And then we can continue one line and then see how this has changed. All right, so we add the breakpoint, and then we have to choose in Unity. This should say attached to Unity, and this is just different in Unity. If this was a regular Visual Studio app, this would be how we test the game, period. Like you play it through here, but in Unity, you play the game in the editor by hitting this play button. So it's just an extra step in the process for Unity here. So you attach it to Unity. And then you'll notice when it's attached, up here this turns into a stop debugging button, and there's a pause button. So you know it's working when these buttons show up, and also you'll notice that these script files there's a little lock icon next to them. So that's another clue that we are in this debugging mode. It also says running right here. So basically we can't make changes to the code while the code is running. And so we're not trying to edit the code here. We're just trying to kind of see how it's working. And we need to make sure when we want to edit again, we'll hit stop. And the other thing to know is that this is kind of performance intensive, so you don't want to just be running the debugger always. You want to be running it when you need to test something, right? So in this case, I have a specific thing here I want to know about, so I'm going to use the debugger. And so now I go back to Unity, and as long as the Visual Studio is attached to the Unity editor like that, when I run the game, it will hit my breakpoints. So in theory, when I interact with this inventory object, we will hit the breakpoint. So let's test it out. And there it is. Sometimes you might notice it does. So for me, it automatically flipped over to this. For you, sometimes it may just seem like your game has frozen and you have to manually click on Visual Studio. So I don't know how to describe why some computers do it one way versus the other. Hopefully you get lucky and it just automatically pops up. Alright, anyhow, right now we are frozen in our execution right here, right before line 35. So line 34 has already happened. Line 35 has not yet. So check it out. If I mouse over this inventory objects list, you can see information about it in real time. So I can see that the count is 0. And if I mouse over this down arrow or click it, you can get more and more information about what is in this list. So right now, since there's nothing in there, there's not much more to understand about it except for the fact that it's empty. But let's see what happens if I advance one line. So I want to choose this button that says step over. When you're debugging, the F11 and F10 hotkeys become very useful. Step over basically just means go straight to the next line. Step into would be like if this was a function. For example, if I stopped on 34 and I hit step into, it would go inside of this interact with function, and then I would start being able to go line by line through that. And then when I was done, it would take me back to this point, and then I would go through like that. So in this case, I'm okay with just going to step over because I don't really care about the inner workings of this. I just want to see what happens when it's done. So step over. Alright, now the game is here. We've finished this line. We're on this one, just about to run it. Haven't yet though. So you can see if I mouse over renderer.enabled, it says, yep, it's still enabled. But if I were to maybe go one more frame or one more line of code down, this should in theory switch to false because that's what this line of code is doing. Anyway, we can look at that later. For now, I want to see if we actually added to our list. So I'm going to mouse over the list, and you can see now it says player inventory objects dot count is 1. And if I were to expand this, you can go in and actually look at the thing, the very inventory object that's in there. Now, unfortunately, we don't have a lot of like identifiable information for our inner inventory objects. Like they don't really have much, but we can change that. And in fact, I think we need to for another reason, so we can figure out kind of more easily what is this inventory object, right? Like remember, if they had their own icon and description field, we could check the value of each one that's in the inventory here like this, but those things don't exist yet. Okay, so I can see that it's actually adding to the list, and just for fun I'll go one more line. So step over, and now we want to see that this changed to false. So it did. Now right now this one's still on true. If I go one line, now I can see that it has been set to false also. And so you can go like this line by line throughout your entire game and just kind of see what happens next. You can see the exact order of execution of everything in your game. Now I'm just in this loop of fixed update forever and ever. Alright, anyway, when you're done debugging, you hit the stop button, or you can hit continue, which will just take us back to our game until we hit another breakpoint, which I don't think there's a way to do because I only had one interactive object. Just a quick note on debugging. I could put a breakpoint anywhere. So if I put a breakpoint here in fixed update, I'll pretty much hit this instantly because fixed update's getting called very quickly. So boom, as soon as I put it in, essentially it hit this breakpoint. So I'm going to take that one out and continue. If I want to put a breakpoint on when the door gets clicked, so I can see what's going on with my door, I can put a breakpoint like right here. All right, that's too far. Let's put it like right here. And try clicking the door, and I bet I hit that breakpoint. Yeah, see, here's a situation. Like I said, sometimes it doesn't automatically open Visual Studio. It seems like my game is frozen. So actually, I'm going to have to hit Alt-Tab to switch to Visual Studio, and now I have my cursor and everything else. So anyway, is the door open? No. Is the door locked? Yes. So you can see all about your door here. What's the display text? Right now it says door. So that's cool. Debugging's cool. Don't be afraid of it. Try it when you get stuck and need to figure out what's really happening. Anyway, stop the debugger and we can resume working on our game. I'm going to stop this. Now I want this when I run the game and look at my inventory object, I want it to say more than just the name of the thing. Right? So it says inventory object. Let's say I changed it to say key, right? Because that's what this is meant to be. And it will say key. But really, I want it to be more obvious that when I click this, it's going to do something special. It's not like when I click this one, it's not going into my inventory, but when I click this one, it is. So in order to convey that to the player, I want to change this text to actually say something like take key. And so I could do that. I could just say take key here. And then it'll say that when I look at it. But the problem is if we think forward to the point where our inventory has a menu, if I were to list all of the display texts as sort of like the name of the inventory objects in the menu, when I look at my menu, it would say take key. Like I have one take key, and I don't want that. I want to say I have one key. So I need to kind of add a little bit more functionality here. So let's go back to Visual Studio. I'm going to get rid of my breakpoint on the door. I'm going to get rid of this. Well, I'll leave that breakpoint for now because I'll show you something. Anyway, I need to add a new serialized field here for inventory objects. This is going to be the object name. So it'll say serialized field, and it's going to be a private string object name. And I better add a tooltip to this to help it be clear what is the difference between the object name and the display text, essentially. So this is going to be the name of the object as it will appear in the inventory menu UI, right? And if you want to remember what our tooltip for the display text is, that is an interactive object. It says, oh, do I not even have a tooltip for this? That's a no-no. Let's add a tooltip for this one while we're thinking about it. So let's add a tooltip to this guy, and we'll say that this is the text that will display in the UI when the player looks at this object in the world. Okay. So hopefully that's a clear enough difference. This is what you see when you're actually looking at it in the world, and this is what you see when you look at it in the menu, right? And so let's think about how we want to use this object name. So remember, we're initializing these fields in the constructor, right? So we're going to go ahead and say, let's go ahead and say that Well, we actually don't need to initialize this one in the constructor because it's right here. So we can just say object name equals name of inventory object, right? Because that's a good default name for this. But the display text, I actually want the display text to say something like take. So let's use our interpolated string feature. So that's the $sign outside of the quotes here. So we can say take space and then curly brackets, and we can type in a variable right inside our string like this. So we'll say take object name, and we need to make sure we close our string. So whenever the player looks at an inventory object, it's going to say take whatever the name of the object is, in theory at least. Let's save this and test the theory. Go back over here and run the game. Make sure you've saved too. Well, actually, before I do this, let's remember. Alright, so I'm going to reset this because it still has all the goofy text I had from before. So let's reset the inventory object so we get our defaults. And so now it says the object name is inventory object and the default display text is take inventory object. And we could customize this also if we wanted. So let's run the game and try it out. That's cool. And so there we go. That worked. Now, you can make this say whatever you want, but at least now we have like reasonable defaults. And it allows us to differentiate what we are saying when the player actually looks at an object here, as opposed to what it's going to say in the menu once the player looks at this object in the menu. So that way you can do neat things, like we could say something like this. We could put question marks here, and then in the inventory it could be like whatever we want it to be, like once you picked it up you understood what it is, or something like it's a mystery until you pick it up. So check it out. We've picked it up, but let's just see what. Let's go back to our breakpoint stuff and see if we can actually read this information somewhere. So we have this breakpoint. Let's remember to attach the debugger, give it a minute to sort of start working, then go back to Unity and hit play. And since our breakpoint is right in the inventory objects interact with method, as soon as I click this, we should hit it. And so right now this will say 0. There's nothing in the inventory until after I execute this line. So we'll go step over once. Now let's look at inventory objects. So it's got one thing in it, and let's see what it is. It is something with the object name yellow key. Pretty cool. So it's working. We have the yellow key in our inventory. Next step, I'm going to go ahead and stop the debugger. The next step will be to make it so that the yellow key is actually what opens this door. So we need to add key functionality for the door. So I think that adding the key functionality to the door is going to be enough stuff that we can stop this video here and cover that in the next one. So that's what we'll do next.